Hello and welcome to the Swim podcast. My guest today is Adam Tornhill, founder and CTO of CodeScene and the author of Your Code as Crime Scene and Software Design X-Rays. What makes Adam unusual is that he comes at software from two directions. He has degrees in both engineering and psychology, and that combination is pretty much the lens through which he sees everything about how code and organizations evolve together. He's one of the people who made behavioral code analysis a real field. And I'm curious to dig into how he thinks about everything. Adam, welcome.
Thank you very much, and thanks for that lovely introduction.
So Adam, let's dig in right away. What actually makes a code base AI friendly? I know you've written something about it recently. Like concretely, what does that look like versus one an agent can't really work in?
Yeah, that's a really important question. So it's something we have been doing some research on, and we have published papers on it. And our hypothesis was that the coding patterns that negatively impact the human, that makes code hard to understand, also have a negative effect on coding agents. So that's what we studied. So we basically looked at, can code quality predict whether an AI agent will do a good job or whether it will just amplify defect creation. And for that, we used a metric called CodeHealth that we have developed, that we have implemented in CodeScene. And what we found that was quite dramatic was that for an AI agent to do a good job and keep defect rates within reasonable limits, you need to push code quality almost to a perfect 10. And once CodeHealth starts to decline, defect rates go up, and they go up quite steeply. So it's a nonlinear relationship. So what happens in that case is that, or rather what you observe, is that some organizations, they really, really get large benefits out of coding agents, right? They're able to accelerate work. And others, they really struggle. And it's very easy to default and blame the tools, but it's not the agent's fault. It's the surrounding context, which is your code, that simply isn't up to par.
When you say code quality, what do you mean? How clean is the code written? Can you explain a bit more about what this quality also health mark you're giving now, to code bases? Can you give us more about that?
Sure, definitely. So when it comes to code quality, in my experience and basically the whole research community, there's never a single metric that can predict something as complicated as code quality. It's a multifaceted concept. So what we do, when I talk about CodeHealth, what I mean is the metric, not only a concept. And what we do in CodeHealth is that we sample multiple properties. Each one of them correlates to one factor that makes code hard to understand. And to give you some examples, it could be things like missing abstractions, right? So you have lots of really complicated Boolean logic in an expression. Or low cohesion, you have stuffed too many business responsibilities into one module. Or you have duplicated a lot of code. So factors like that. Mm-hmm. We sample these, and then we have algorithms that can simply convert them into a numeric range, 10.0 perfectly healthy code, all the way down to 1, which is the worst possible technical depth you can imagine.
All right. So let's take this approach into the real world challenges. And I know you've tested agents going into legacy code and guided. So what happened?
Well, what happens is that defect rates soar. And there are plenty of pretty good studies on this, and our own included, of course. What you typically observe is that you get a large increase in defects, and the typical number tends to be around 40 to 50% increase in defects without any increase in throughput whatsoever. Mm. That basically means that code quality or quality of the product goes downhill, but you're not even getting there faster, right? So that's one typical thing that happens. And the reason for that is, of course, that legacy code tends to lack abstractions, and it tends to be really, really hard to understand for humans. Now a coding agent comes in, and it's very hard for the agent to even bridge the gap between the the problem you're describing through a prompt versus what the code reflects. There's no natural mapping between them. So even the search operation of an agent is complicated. And when the agent is then tasked to change the code, it will be more or less a hit or miss. And what we see is that if the code is unhealthy enough, hallucination and error rates might be as high as 80-90%.
Wow, that's incredible numbers. So we're talking now at Swim with a lot of managers. Sometimes, by the way, it can be the CEO himself or herself and the CTO, of course, that are trying to bring AI into legacy systems, right? So they want to see if you can work with or modernize it or different outputs that you could hope with AI to achieve. So, in your eyes, where are engineering managers most wrong right now about the legacy problem?
So when it comes to a legacy problem, I think what most people get wrong is that they think that all code is equal, and they think that the marketing promises of stuff like 55% faster and whatnot,
Right.
they think that that's universally applicable, but it's not, because your existing system, your existing code base, it's such a critical part of any agent's context. And it's very easy to underestimate that, perhaps because you don't know where you are today. You don't know how bad it is. So that, I think, is part of the challenge. That said, I've been working with trying to remediate technical debt for like 15 years now. It's basically what I built my career on. And I'm quite enthusiastic about coding agents because I think it's finally the tool we need to solve this big problem of legacy code and technical debt. But it won't come easy. In my experience, succeeding with coding agents requires even more discipline than doing stuff manually.
That's quite an interesting statement. So when you say the legacy code lacks this context or this layer that enables agents to work with, what do you mean exactly? Is that the fact that it was written in older languages or implemented in a different way, or the lack of documentation, or what is missing there? What is the missing layer?
So language itself, I don't see as a big enough problem. What I think that the problem is about is a lack of good enough design in the code. So typically what you tend to see in legacy systems is that the implementation is very low level. It's almost like a brute force. You tend to have really, really long methods spanning hundreds, sometimes even 1,000 lines of code, right? And there are very few abstractions. So there's usually a lot of logic, a lot of if statements, nested if statements, loop, but nothing in the code that tells you that this is the actual problem that this code solves. And that means that without having good abstractions like good functions, properly named classes and modules, it's going to be really, really hard for a coding agent to build up any context and understand what that code actually does. And that's why it's so risky to change it, both for humans and machines, in my opinion.
Understood. There is no clear statement of why it is doing what it is doing, and nothing also about what it is actually doing.
Yeah, exactly. Exactly.
Okay. So,
And sometimes we can compensate for that by having really, really good tests, right? But that also tends to be the hallmark of legacy, that you don't have any automated tests.
okay. So now trying to extrapolate from this problem and making agents work with this, complex code bases. So what kind of context, I don't know if that's the right word you like to use, makes the biggest difference for an agent to be able to work in complex code bases?
Yeah, that's an excellent question. So based on everything I've learned, I would say that CodeHealth is really, really vital, because if you have a healthy code, then you can also let an agent create tests, and these tests will be quite good. And you can also use the agent to start to accelerate feature development. So what we see in our research is that CodeHealth needs to be at least 9.5 on a 10-point scale in order to do fully autonomous feature development with agents. So what I think is missing is the situational understanding, right, of which parts of your code are AI ready today, because I'm pretty confident that most legacy code bases have parts of the code that are actually in quite good shape.
Mhm.
And if you can identify those up front, then those are the parts we can already today start to accelerate with agents.
Okay.
And other parts that might not yet be AI ready, it's super important to be aware of that and have realistic expectations and plan accordingly.
So the strategy you recommend is low hanging fruit, right? So like first understanding within the code base what is better or healthier and can work out of the box with agents, and then the rest you need to deal with. So let's talk about the rest. Let's say there is a company, 12, 15-year-old, maybe 20. It doesn't have to be a 60-year-old bank, right? And they have, I don't know, 5 to 10 million lines of code. Um, it's not greenfield, right? And they realize their code base is blocking them because of this code health situation. What do? How do you help them, retrieve this context to, unlock agents on their legacy code?
Yeah. So what I do in those situations is that, first of all, I do this pure analysis of CodeHealth, just figure out where are the problems and where are the parts that are already AI-friendly. After that, I start to look at business relevance, because if you have a code base of 10 million lines of code, chances are that not all of it is actively maintained. In fact, 90% of the code tends to be quite stable. So that's the parts of the code where you can maybe accept existing technical debt. You can accept a lower quality because chances are you won't really work on that part of the code. So it's all about identifying the business critical parts of the code. And there are techniques you can use to guide you on that. One of them is the hotspot concept that I talk a lot about in your code as crime scene, that basically identify those parts of the code. So now, when you have identified the business critical parts of the code, those are the parts of the code that you want to make AI ready in case if you really want some return on investment. And from here, there are multiple technical techniques I would use. And it would also depend on CodeHealth, because what we also see in our research is that if you have on this 10-point scale, you can have quite severe quality issues. As long as they are above, say, roughly 6.57, then you can actually do an agentic uplift.
Mhm.
Coding agents are quite good with that if they get this information, this context and direction.
Okay.
And the way we solve that in practice is that we provide CodeHealth through an MCP server to the agent, so it gets a direction and a goal.
Mhm.
If you're below that limit, if you're in truly unhealthy code, then you need to be quite strict with having a human in the loop to guide it.
Mhm.
The big difference is that you can now do these costly code transformations. You can automate them through an agent, but you need to do them super iteratively and build up, just like you would do any refactoring. The difference in my experience is that refactorings that used to take weeks, you can typically do them within a day with
Mhm.
agents, because the feedback loop is so rapid.
And especially in the part that you have identified as healthier, right? That's the places where you would start. And that, I guess, through your technology, you can also recommend your clients to start, working with agents on this more, healthier parts and more important parts, maybe in terms of the business. Very cool. So in the prep call we had, you told me you're working yourself, using agents and hands on. So I have a question about this experience after a year of agentic development. Where do you trust the output without looking? Accept, or when do you feel you still need a human in the loop? Besides these areas where the context is extremely rare and challenging.
Yeah, so I would say that there are two different types of tasks that I generally work on. One are like pure maintenance tasks. So to give you one example, let's focus on the CodeHealth metric since we talked about that. So under the hood, CodeHealth is supported for, I think, 29, 30 different programming languages, which means for each one of these languages, we need to parse the languages, we need to do an analysis and interpretation of it. And programming languages aren't stable. There are changes to them all the time. So there's a new operator introduced in C++, a new syntax in Java or whatever.
Uh-huh.
And this used to be quite time consuming. But this is a part that I have found that agents are quite good at. And the reason the agents are good at that is because the design in our product there are some predictable patterns for the agents to follow. There's a very strong test suite that can serve as good examples for new tests that need to be added, and that can work as validation criteria as well. So those are the parts where I can give an agent full autonomy. The parts where I have found that I need to be much more tightly involved in the loop is when I do something novel that we haven't done before. So not really any existing context, not really any existing examples. And that's where I need to, take much, much smaller increments and validate as we go along in general.
Interesting. So, as a specialist about code health and complexity of code bases, I have this discussion with a lot of engineering managers about how fast new code will become legacy code now, right? Because it's being written so fast with agents and at scale, because everybody becomes a developer now, which is another challenge that engineers will need to deal with. But you've mentioned that, in legacy systems in the past, there was this lack of design maybe, and in the missing context. Is it better now as it's being written faster and, at larger scale, or it's just bringing the problem faster than it used to be?
I would definitely say that AI really just accelerates existing trends and existing outcomes. So we get to bad code faster.
Interesting.
And that's to me it's really, really dangerous. I've seen so many companies that naively adopt AI, and it's easy to do a proof of concept, right? So even if you do it by the book and say, okay, let's evaluate this with a small team, and you might even look at benchmarks and whatnot. The problem with almost all these tasks is that there are one-off tasks, and that's not how software development works, right? With software development, 95% of the costs come after the first release of the product.
Right.
So that's the maintenance phase. And this is where agents need so much more guidance. And this is where engineering discipline is more important than ever. So in my take, it's not only about new tools, it's also about reinforcement of the fundamentals of software design and the fundamentals of software engineering. It's more important than ever.
So, okay, let's talk about this discipline element, because that's something that is like less sexy than running with agents and building, right? And so I think the models are super exciting nowadays, and I think we're past the model choice, right? That the main variable. But what is the right? So if we're talking about the discipline, what is the right infrastructure around a model? What does it look like? What engineering managers need to be aware if they are starting to release products that were fully written by agents, right? And they're going to hit quite quickly, as you mentioned, the maintenance challenge. What do they need to prepare for?
So I would say that there are a couple of things. The first is to have safeguards and automated quality gates at multiple levels. So what we do internally is that we have a bunch of safeguards that run already as the code is being written, right? So these safeguards are implemented via MCP servers and CLI tools. So they give feedback to the AI as the code is being written. The other thing we insist on is to have good tests. So we've always known that test automation is a good thing. Everything we can check automatically, we should.
Right.
But we never really cared about the extent of it as we have to do now. So what I found is that we have to get almost to 100% code coverage for everything we do in order to be able to trust it. And that's used to be quite extreme, but now it's a must. And then, of course, rapid feedback loops are really, really important. It doesn't help even if you code twice as quick and then you have to wait 2 hours for your build pipeline. It's an extremely long feedback loop. To me, the big open questions in this space when it comes to safeguarding is around software architecture and design.
Mm-hmm.
So that's where things also can deteriorate, and that's a space where I'm not aware of any good automation or tools today. But
Right.
I think it's the next frontier.
So it's still a heavily human in the loop in terms of the design. That's what you think?
Yeah, I think so. And again, a good design can serve as a guardrail in itself, right? Because it sets an example, it establishes a pattern that AI can follow. But
Mhm.
we need to get that right. So what I tend to do is when I do something novel, I always spend much more time up front on it than I used to do,
Mm.
because only so can I accelerate later.
So the load of the work changed a little bit from working on the output, and it goes upstream, you would say, to the design and preparation before sending your agents to the work.
Yeah, I would say so. And I
Okay.
also tend to be much more strict in how I work, right? So
Right.
I found that some things I used to do might no longer be meaningful. For example, I no longer do test-driven development in the sense I used to, but I do insist on having end-to-end tests written before any code whatsoever is produced, because that's how I validate that I have managed to specify the right thing to the agent.
Right. So that's the Spider-Man. With great powers comes great responsibilities, I guess.
A bit like that, yes.
Okay. So as I mentioned in my introduction, you come at this from psychology also as much as engineering, right? Um, can you tell us a little bit how you see the world and what does psychology actually explain about code bases that are, pure technical approach misses?
So I think what psychology brought me was on a better understanding for how we people think, reason, and solve problems, and it has influenced a lot of the stuff I've done. So the whole hotspot concept,
Mm,
it's a behavioral analysis technique. That one I actually picked out of forensic psychology. So it's
mm,
based on a method for tracking serial offenders, right?
yeah.
In our case, we're tracking code that is being modified frequently, but it has also influenced how I view code at a deeper level. So the human brain, as fascinating as it is also quite limited. We have so many cognitive bottlenecks, things like working memory. How many things can we hold in our head at once? And that has definitely influenced how I approach software design. So I think a good design is a design that works with the human brain rather than constantly trying to fight it.
Mm,
And if we have followed those recommendations, then that pays off now, because coding agents, they are trained on humanly written code, right? Even synthetic training data looks very much like humanly written code.
mm,
So that means that they are sensitive to exactly the same problems as we humans are. So I think
right.
psychology is more important than ever. And then, of course, now with coding agents, I reflect a lot about how does it actually impact us as human developers, this massive shift that happened over the past year.
Can a coding agent can also be your psychologist, or how does it work?
Oh,
Oh,
I'm not sure about that. It's interesting with agents. I have to say that I have never had as fun writing code as I have
mm,
now with agents, because I can take on larger problems and I can get there faster. But I also find that it's quite draining. So I
mhm,
used to be able to code for a whole day. There's no way I can do that in agentic work.
mm,
After 2 hours, I'm completely fatigued mentally,
yeah,
because what an agent does is basically it compresses the amount of decisions you need to do into a very short time span, and that is draining.
right. It's rubber duck debugging on steroids, right?
Yeah, it's a bit like that, and you have to pay attention constantly, and then you also have these, you have these interruptions. That I think is a big problem with agentic workflows today. That you instruct the agent, hey, do this, and you never know how long the agent is going to need. But you assume that, yeah, it'll probably be a minute. So you go to LinkedIn or X or whatever, or Reddit, and now you lost 10 minutes surfing the internet, right? And you start to multitask. So that I think is the problem right now, that
Mm,
agents are like an open invitation to multitasking and lost
right.
focus.
You lose the zone like experience that developers used to have, right? With the
Yeah,
headset.
exactly.
Mm,
Because there's so much wait time in the loop today.
mhm, understood. Interesting. Okay, last question. You're one of the founders or the founder of CodeScene, right? And if you were to build it today from scratch with AI, what would you do differently?
What would I do differently? I mean, there are, we always been good at CodeScene focusing on engineering discipline, but what I would have done would that I would have turned that discipline from 10 to 11 on day
Mm,
one.
mm,
And when it comes to feature set, there are probably features that I wouldn't have considered because they might no longer be relevant in the AI era. But the
yeah,
fundamentals are more relevant than ever, so I would have doubled down on those.
yeah. That's interesting. I think a lot of companies, either their business went, down because it's not relevant anymore, or some the essence of the business is even truer now. It's more important. We started with documentation, and suddenly it becomes like a must rather than something that people, put aside. Um, Adam, thank you so much for joining the podcast. I learned a lot, and I think your unique approach and experience, and also the way you're articulating your experiences and how you encounter these challenges, I think is humble and interesting and helpful. I think for many managers that will see that, hear this podcast, and think about how do I build the right discipline into my my team, in my workflows, in my infrastructure. And I think we've passed the hype, right? And now there is room for a more structured, serious look at how we are going to deliver the software of tomorrow. So thank you for your input and for the learnings, and hopefully we can see you soon again.
Thank you so much, and thanks for having me.
Pleasure.